Today, we're going to talk about a technology that is totally changing how AI sees the world. And believe it or not, we're going to connect the dots between finding the best route for a 30-ton truck and the smarts behind your favorite apps. Let's jump right in. Okay, so what on earth does a giant semi-truck have to do with your favorite AI? It sounds like a riddle, I know, but the answer connects this really gritty, real-world logistics nightmare to the sophisticated intelligence that you're using every single day. It all boils down to solving an incredibly complex puzzle. So let's start with that puzzle. It's kind of like a modern-day version of the classic traveling salesman problem. Just picture it. You're behind the wheel of a massive semi, and every single gallon of fuel is money out of your pocket. Your goal is simple. Finds the most fuel-efficient route between a bunch of different cities. But here's the catch. You're driving a 30-ton truck. Quick U-turns? Forget about it. And modern highway systems are just a massive labyrinth of pathways. Finding the truly best route is, well, it's next to impossible with a regular map. To solve a problem this hairy, you're going to need a search function that's way smarter than just looking for city names. We need a serious upgrade.
And this is where things get really interesting. We're all used to keyword search, right? It's literal. You type in red apple, it finds red apple. But vector search, it's a whole different animal. It understands context, it understands meaning, it gets the relationship between things. It's searching for what's similar, not just what's spelled the same.
So how does it do that? Well, the magic behind it is something called vector embeddings. It's a way of turning really complex stuff, like text, pictures, or even map locations, into a simple list of numbers. We call that list a vector, and that vector holds the essence, the real meaning of the data. So a computer can compare concepts, not just words. Okay, so that's the big idea. Now let's bring it back to our trucker and see how this actually helps plot that perfect route. First up, you'd build a data model that looks something like this. See this location vectors table? Each city isn't just a name anymore. It has a location vector. You can think of this like plotting each city as a single dot on a simple 2D map. Now, by asking the database to find the vectors closest to our starting point, it can instantly spit out the nearest cities in a straight line. It's a great first step, the as the crow flies solution. But this brings up a pretty obvious problem, doesn't it? Exactly. Last I checked, trucks can't fly. A straight line is useless if there's no highway. It doesn't account for the actual roads, the bridges, the tunnels that connect everything. So clearly, we need to get a little more sophisticated. And this is the genius next step. Instead of just plotting the cities as dots, we plot the highways themselves. Every single segment of road gets turned into its own vector, representing where it starts and where it ends. This is where the real power kicks in. So now we can ask the database a much smarter question using a special query called Approximate Nearest Neighbor, or ANN. We basically say, hey, database, here's my start and end point. What's the most logical chain of highway vectors to get me there? Now, that word approximate is key. Why? Because finding the 100% perfect path might take minutes, but finding a 99.9% optimal path takes milliseconds. For our trucker, and for pretty much any AI app, that trade-off is a no-brainer. The database instantly gives back an ordered list of highway segments, and boom, you have your route. Problem solved. The trucker story is a fantastic way to get your head around the concept. But the crazy part is that this exact same technology is already all around you, working behind the scenes in ways you probably don't even notice. That same idea of finding what's similar is what's running the recommendation engine that knows what movie you want to watch next. It's what makes search engines understand what you mean, not just what you type. And it's how chatbots can pull up the right information to actually have a conversation with you. Yep, it's all vector search. And here's why this is such a game changer for the folks building these tools. By putting vector search right inside a database like Apache Cassandra, developers don't have to glue together a bunch of different complicated systems just to add AI features. It makes the whole pipeline so much simpler, which means they can build the next wave of smart apps way faster. Which brings us to the really big picture here. Because what we're talking about isn't just some cool new feature. It's a fundamental change in what a database is even for. You can really see the evolution here. Databases started out as, digital filing cabinets, just a place to store stuff. Then they got a little smarter, they could run basic queries and process the data. But now they're becoming true partners for AI. They can actually understand the context and the meaning that's hidden inside the data itself. This quote just nails it. This isn't some far-off future prediction. This transformation is happening right now. It's opening the door to a whole new era of AI-driven innovation.
So I'll just leave you with this question to chew on. What if your data could be more than just stored? What if it could actually be understood? That is the incredible, intelligent future that vector search is unlocking for all of us right now.